what I've kind of learned through the semesters is this, that, I need to do 2 graphs. I knew that the first time I read the problem. But what I've learned is it's probably nice if I do the 2 graphs, one under the other for this problem. And these are things, as a teacher, you're going to learn from your mistakes. And I guess I wouldn't call it a mistake, but you're going to learn the second and the third and the fourth time you teach the class how to do better than what you did the first time or the second time. You know, that'll happen. So this is something I learned from this problem. One of my graphs I'll put like this. Kind of hard to draw it straight and holding up the camera. So I'll put one graph like that, and you could extend this a little bit like the XY axis if you like, but I really don't want negative values here. My second graph, I'm going to try to line it up. This is what I learned as I taught the class a lot of times, is to line up the second graph with the first one. What does the horizontal axis represent? Time. So, time and time on both of them, right? Now the first one is her distance from street level. Maybe it should say distance above street level. So let me label the first one, distance above street level. The vertical axis would represent what? The distance. Distance above street level. On the second graph, what does the vertical line represent? Speed. Now this next question, this is something I've seen in the elementary curriculum. Questions like, what units make sense? Have y'all seen that on some of the things you've been working with the kids? Yeah. In 3rd grade, 4th grade, when they learn in centimeters and meters, and they want to measure something, what units make sense? So what units make sense for this problem? Let's talk about time. Minutes? Seconds? Minutes? I would think you could probably give a good argument for either one of those. She's walking up the hill. How tall is this hill? We don't know, but what would be a good unit for the height of this hill? Meters, or feet, or yards. But we could do some of those. And you know, part of this depends on what you've experienced personally in your life. You know, hills. What do you think of when you hear this hill problem? Do you think of the Indian mounds? Do you think of something taller than that? Do you think of the mountains? Are you hiking in the Rocky Mountains and there's a hill? And so, you know, it depends what you're thinking about when you hear the word hill. So what units do you want to use here? Distance. We'll go with feet, meters, yards. Let's do feet. Okay. And then time-wise, what kind of But kind of on the time, I'm thinking, do I want to do seconds? I don't know how long she's going to stop to rest. Is she resting for 10 minutes? If she's resting for 10 minutes, then seconds probably would not work too well. If she's only resting for a minute, seconds might be okay.
But are we making it up?
We're making it up. So I'm just kind of going over what the options are.
Okay, I would rest for that.
Rest for how long?
For a minute.
A minute, 1 minute. So you want time in minutes or seconds? Minutes. Okay, so if we do time in minutes, on both of these, time in minutes, if I want them consistent. What units would I use for speed? Feet per minute? Ooh, that would be, okay, we could. There I'm thinking, I'm thinking seconds would make sense there. But feet per minute, how many feet can you walk in 1 minute? Probably a lot, right? Yeah, probably a lot. So, but that's okay. We'll go with it like this. Now, every time I work this problem, I probably work it differently. Let's do the distance above street level. So, it didn't say this, but I'm thinking she's starting at street level, right? She's starting at street level. She's walking up the hill at a constant rate. Let me grab a different color to write with here.